Hello and welcome back to Mr. Powers Teaches. What is this? What is this? Algebra. We're doing algebra. Good to be here and see you guys. Hold on a second. What's going on? All right, there we go. We're all set now. My graphics tablet decided it wanted to do the other window. I don't know who to blame, Veek or Windows. But in any case, we got something to talk about. And what is that? What are we talking about? It looks like function notation. That's what we're going to talk about. And so what I have here are three different functions. That's right, three. All represented in different ways. I got g of x here with that is a table. Maybe it's a function, maybe it isn't. We'll assume it's a function since we're doing functions. F of x, definitely a function. H of x here. H of x is a graph. It's a function, but it's represented as a graph. F of x is represented with an equation. G of x is a table. And so I'm going to use this video and these different representations of functions to illustrate and explain function notation. All right, and that's all it is a notation. So most students, when they learn function notation, it's nothing new. Your notation is just the way you write something, maybe the way you say something. It's new language, but it's nothing new. So it's something you've done before, it's just writing it a different way. For instance, f of negative 5 right here. Let me see here. I'm going to do this. Okay, here, let's try that again. All right, so f of negative 5, hold on here. We're going to erase. Okay. F of negative 5 right here. Okay, f of negative 5, that really means, okay, when you see something like that, it means what is y when x equals 5. That's what that means. What is y when x equals 5? And right here, you see f of x equals, there's f. So there's f. That means I'm going to use this one. I'm not going to use the graph. I'm not going to use the table. F, here's my f of x. F of x equals 2x squared minus 6x plus 3. Now I said y, but really, what I mean is we could imagine this. F of x equals the same as we would back when we said y equals 2x squared minus 6x plus 3. Okay? It's the same thing. Just now we're replacing y with f of x, and now instead of saying evaluate when x equals 5, we say find f of negative 5. I'm sorry, x negative 5. My bad. This is f of negative 5, so it should say x equals negative 5. Okay, so that's what it means. Instead of saying evaluate when x equals negative 5, we're saying find f of negative 5. So it's just shorter, easier. It's a little bit more powerful in some situations. So we like this function. We like this notation. We're going to use it from now on. Why don't we use it to begin with? I don't know. But we're going to use it a lot more now. It's going to be very useful. Anyway, so something we need to get used to. But that's all it means. And so a couple more examples here. When, like, say for g of x, I got this function here, g, and I got negative 1 comma negative 9. We got a table here, negative 1 comma negative 9. That's a point on the graph of this function. All that means is another way to write this is the same as f of negative 1 equals negative 9. So here we'll do a double-sided arrow. These are the same thing. F of negative 1 equals negative 9 is the same as saying when x is negative 1, y is negative 9. That's all it means. We can do one more here. Okay, right here, this is a point, 3 comma negative 2. And that's the same as saying that f of 3 equals -2. It's the same exact thing. Okay, so that's what I mean. It's like nothing new. This is just notation. It's just writing it a little differently. Okay, so now that we got that out of the way, let's go ahead and find what's f of -5. Again, so that means, well, what is, it means evaluate when x is -5. So let's do that. And we're going to do some evaluations here. I'm going to do a few. Okay? Oh, and actually, I shouldn't have been using f here, right? I'm so used to using f, but this is g. So let's fix that. This is actually, both of these should have been g. So that's my bad. G of -1 equals -9 because I'm doing g here. And this is g of 3 is -2 because this is g. I should be using g. Okay, and that's another thing, is that we can talk about multiple functions at the same time because now we're kind of naming them within this notation. So that's kind of nice. Now let's go ahead and find f of -5. So the way I'm going to do that, I'm just going to kind of scroll over here. Here's my definition for f of x. So right here I get, well, f of -5. So one way to think about this too, and this is the way I like to think about it, is if on the left side I replace x with -5, then on the right side I replace x with the same thing. That is a very important thing to do also. So f of -5, instead of 2 times x squared, it's going to be 2 times -5 squared minus 6x, so minus 6 times -5 plus 3. All right. So I'm just going to do a little separation here. So what are we going to get? This is -5 squared is 25. So I have 2 times 25. And then -6 times -5 is 30. So plus 30 plus 3. So that's really 50 plus 30 plus 3 is 33. So we get 83. So f of -5 equals 83. So if I wanted to solve this little problem that was presented to me, that's how I would do it. Piece of cake. So that's all you got to do. Let's do a few more examples. We got g of -1 is -9. Let's say what is, let's do one with more with g. Let's, how about g of 6? What does g of 6 equal? Well, right here, it's not, instead of g of x, it's g of 6. So when x is 6, here it is, g of x is 2. So g of 6 equals 2. There we go, and we can see that right here. Okay, now let's go back and look at h. Let's go back and look at h. H of x right here. Let's do a couple things with h of x. All right, so right here, let's say I wanted to find h of, I don't know, 2. So that's saying, well, x is 2. What is y when x is 2? Well, x is 2 is right here. I have a point 2, 0. Well, that h of 2 equals 0. Great. What if I said I wanted to find, let's do one more for h. H of, I don't know, let's say -2. -2, why not? So I go back. -2 is my x. Here's the point on my graph. That is at -2, 8. So that means h of -2 equals 8. There we go. All right. Now I want to do one more thing. Function notation is very, very powerful. It's very useful. So let's take a look at this guy right here. And let's say I want to actually get f of something a little bit more complicated. Rather than, let me see here. I think I want to do x plus h. Is that what I want to do? Give me 1 second. Yes, I've decided. I want to do f of x plus h. We could really do f of anything. We could do f of x plus h, f of x plus 3, f of 3x. We could do whatever we want. But I'll go ahead. I'm going to do f of x plus h. So again, here's the thinking. If I change x to x plus h on the left side of my equals, do the same thing on the right. So instead of 2 times x squared, this is going to be 2 times x plus h squared. All right? Okay, so we can figure that out. Minus 6x, so it's going to be minus 6 times, not x, now it's x plus h. And then plus 3. And so you got to love this, huh? You thought we were complicated enough in Algebra 2. No. Now we can do all sorts of fun things. Wait till we do functions of functions. Well, this is kind of a function of a function. But we can do this with the notation too. We can do all sorts of fun things. It's too much fun. So, well, you got to do the exponent first. So I'll go ahead and finish this example. But you should get the idea now, how we can you do function notation, how we use it, and what it all means. So x plus h squared. Well, what is that? That's x squared plus 2xh plus h squared. Okay, and then we got minus 6 times x plus h, so that's minus 6x minus 6h. And then we got our plus 3. Okay, so it's getting a little messy. That's no biggie. Then we got 2 times x squared. We'll distribute this 2 in. 2 times 2xh, that's 4xh. 2 times h squared. All right. Minus 6x minus 6h plus 3. So really, again, even doing this is nothing new. We've done what's on the right side here. We've done stuff like this before, but now we can use this notation to set up problems. All right, so now we combine like terms. X squareds, well, there's only the 2x squared, so we're okay there. 2x squared. And then I guess, what? Should we do x's? Let's do x's. So there's minus 6x. I don't see any other x's, so we'll say minus 6x. Okay, and then let's do xh's. So there we go. I only see that, so plus 4xh. And actually, I don't see any like terms. So there's 2h squared. Actually, I'll do this minus 6h first. So let's do minus 6h plus 2h squared plus 3 is left. That would be it. I'm done. Yeah, so that's kind of ugly, but hey, we did it. We're done. Piece of cake. So that's it. There's my explanation of function notation with every way, lots of ways functions can be represented. So until next time, enjoy doing math.